Hey folks, this is my third attempt at this lecture. Last time I broke this computer a little bit. Don't tell my husband. It's his setup. So I was trying to show y'all real quick a little bit about how to make an assembly if you're interested in making assembly. You don't have to, but some people were messing around with it in class. I figured I'd get you guys a sort of crash course in it. What is an assembly? Usually when you open up a project in Onshape, when you first start one, let me open up my other one that I made. This guy. Normally when you start one up, it'll automatically have an assembly tab and a part studio tab down here. I've deleted my assembly because I messed it up twice, and you can always add a new one if you don't see one or if you want to make another one. Create an assembly. What an assembly is you can take multiple parts. Like right here I have two distinct parts. They're usually different colors. If they're different parts, it'll automatically color them different colors. And there also will be more than one part in your parts list. So here's my my assembly I'm going to make. I've got to insert my parts. Here is part one. I guess I can choose where to put it. Huh. And there's part two. And if I don't move the mouse around, it'll just put them related to the origin the same way they were in the part studio. There are my two parts. And right now, just like in the real world, if I have these two parts printed out by a 3D printer, I can change their location. I can move them around. Relation in 3Space, and it sort of intuitively guesses where I want to put it. I'm gonna quit moving too fast, so because I think that's why it froze last time. Let me undo my movements. There we go. I can also, if I click on it, I can grab the arrow and move it just up and down or just back and forth, left and right. And I can also grab this little circle thing and I can rotate the whole part around the top piece here if I want to. I don't want to do that though. So there are several degrees of freedom when you have something like this. A degree of freedom is just something like I can move it in a certain dimension. I want to say there's 6 degrees of freedom. I don't remember how to actually quantify degrees of freedom, but I can move, like translate something left and right and up and down and backwards and forwards into 3 dimensions. There's 2 directions in either dimension, so there's 6 directions total. And then same thing with rotation. I could rotate around like the x-axis. I could rotate counterclockwise or clockwise around the x, counterclockwise or clockwise around the y, and counterclockwise or clockwise around the z. It's a lot to say it like that. You can think of it like if you're in a flight simulator, there's pitch, there's tilt, there's pitch, and then there's turning left and right. So there's a lot of words associated with this that I'm not sure I'm finding just in my brain from my random past knowledge, but there are words for these things. So what a mate will do, and that's what these are all called, mate, some sort of a mate, that's just a way to fix it in place and remove some of the degrees of freedom so it does not move completely freely anymore. You have this one here as a fasten mate. I was trying to do that, and that's one of the reasons why I had to restart. I was trying to fasten this base down to the origin. The origin is the only geometry that you get when you open this. You don't get the planes, you just get the origin. I was trying to stick it to the origin so that I could like move things around it and not have the base move around as well. But that didn't work. And that means I just have to read more on it, and I'm really interested in it because I didn't figure it out immediately, so it's really interesting to me. Like, I want to know how it actually works. We want to do a revolute mate though. That'll basically fix 2 pieces to have a same axis that they share, that they can rotate around, but they can't move off that axis. So they rotate about the axis only. So what I'm going to do, and this is where mate connectors come in. If I hover over my parts, I will see this little mate connector thing pop up anytime I'm anywhere near one of these vertices, or the center of a plane or something. There's a center of a plane, there's ones along the midpoints and at the corners of everything. Every single face and every single actual round area should have. I wonder if these do. No, that's at the corners. Anyways, this right here, for example, I want there to be like an invisible axis down the middle, that lines up with an invisible axis down the middle of these two, and then it can't move off that axis. It can rotate around, but it can't move off of that axis. So I'm going to pick a connector, and when I first did this, I picked the connector in the very center of this cylinder, and then I went and I picked the connector like right on the center of this circle part right here, and that did that. And that's okay. I can go and I can offset it, I can move it. I just don't remember how far it has to go, so it would be much better actually if instead of these two, undo. Oh no, put them back. There we go. Instead of those two, I'm gonna pick this one at the edge, the left edge, my left, and the left edge of this guy here, and that way at least it's kind of right there. Move this out of the way. So you can see where it lives now. They're lined up. Those circles are kind of perfectly lined up together, and they're touching each other. But there's a bigger gap over here. What happens, if you remember from the other videos, that this cutout here is 35 millimeters, and this hinge part, the gray hinge part's only 34 millimeters, so there's a little bit of leeway here, and it doesn't get too much friction between it. We can offset it by a ½ millimeter. I'll show you what happens when I put in 0.5, so if you do this on your own, you're not freaking out. Oh no, it's moved it farther, and it's now like in the middle here. They're going inside each other. That's not what you want to have happen. They can't do that. There's material there. It won't work. So let's put a negative sign in front of it, and that'll move it the other direction. And now you can see there's a little gap on the left here, and there's a little gap on the right side, and that's exactly what you want. And now what happens, let me make it, get a nice view here. Now what happens is if I go to rotate this guy, or if I try to move this, first of all, let's move this around. Let's slide this top piece. The bottom is stuck to it. They go together. Wherever they go together now, because they're basically stuck on an invisible axis between all these things. Okay. Let's undo that move around. And if I go to rotate, like I can actually rotate this piece relative to the base. And then I can rotate it all the way around. And what looks like it's happening is it's rotating kind of around an axis in the middle of this thing. If I had been able to stick this bottom part down to this dot to the origin, I wouldn't have that issue. I'd be able to just close it and open it, and this would stay put. Oh well, it's okay. But you can see now they're stuck together. The problem I might want to address is the fact that I don't want this guy clipping into this or clipping into the back here. So what I did is I put some limits on it. I said I can put a minimum, like I don't want it to go more than 90 degrees this way, because otherwise it's going to hit and go into here. So if I put 90 degrees or 90, oh, look at that though, it made it 90 in the other direction. Hey, let me put a negative sign, and that'll make sure it doesn't go anywhere past negative 90. I guess positive is going to go that way. Maximum, I'm going to put what I put before, which is 150. 180, if I rotate that 180 degrees, this lid is going to smash into the back here, and it can't do that in real life, so let's make it slightly less than 180. And then I'm going to show you what that looks like. I can now move this around, and it won't go past. And when I start to rotate it farther, like it moves the actual piece around, the actual bottom piece around it. All right. Same thing this way. It won't go farther. It'll rotate the other piece around it. Let's undo that rotation. And I can animate it now, which is really fun. You can just watch it close and open and close and open. Right click, animate, hit the play button, and there it goes. It rotates. And if you watch on the back side, it does not, well, maybe a little tiny bit in here. It doesn't really intersect with that at all. And it stops there, and it opens up again. And it's just fun. It's fun to play with. It's good for showing off for people, you know, be like, hey, look at this cool thing I designed. Look what it can do. It can rotate. There are all kinds of different mates. You can have it so that I can have a slider, like if you have something that telescopes out. We did a selfie stick, and there might be a selfie stick later on in the year for you guys. Since I did it, it might be in your curriculum too. This one is a planar mate. Like, I guess you could slide it along. They'd be stuck to each other, but you can slide it around left, right, up, and down on that plane. Cylindrical, that probably has to do with not only rotating, but also translating up and down an axis. Pin in a slot. can put along the center of the slot. Anyways, there's a lot of options. There's a lot of stuff to play with. There's stuff that I haven't even played with over here, and it's really fun, and I hope to play with it later. Just not right now, because y'all are probably like, Ms. Haynes, when are you going to shut up? It's time to go. Here's the one I made and I printed off. That has this piece in it. If I animate the revolution, you can kind of see that this tab, as it's drawn, as it's built in here, it kind of intersects with this stuff right here. And that's okay. That's, you know, what's going to happen when you actually print it out of plastic is it's going to be somewhat flexible, and so it will actually bend back a little bit as it goes past this stuff, so it doesn't actually slide through that part of the material. But hey, let's do a quick animate. There it goes. You see it kind of, and let's wait till it comes back. You'll see it again. It kind of slides into here, and it looks like it goes right on through. Again, that's just because, you know, it's modeled as a rigid body in here. So anyways, I'm going to stop this before I ruin all of my graphics processing power on this computer. I'm going to close some of these things, and I am going to sign off, and I will talk to you guys another day. Y'all have a great one.